surfaces will be okay. This surface will be insulated so that the heat will flow only along the length of the rod. At T equals 0, the temperature of this body. This is source. So source means what? Temperature will not decrease. Though it loses heat, temperature will not decrease. Already we know. It's a body, thermal conducting body. This one. So the temperature of this S, as it absorbs heat, as it acquires heat, the temperature of that will gradually increase. So I'm just interested like what is the expression for temperature of this body as a function of time? At T equals 0, the temperature of body is T1 or T naught if you want to write T naught. Find the body at any time T. This is our discussion. So now from where this body is getting heat, the body is getting heat through what? Through the thermal conducting rod. So what is the basic idea of this problem? The thermal conducting rod will supply heat to this particular body so that the temperature of body will increase with the time. I want that temperature. So what is the formula? We can write it as like H is equal to area of cross section. Heat will flow here. Area of cross section of this, let it be A. H is equal to Ka, temperature of source minus T by L. Will I agree this? You should try to now take help of this one. This expression for heat current. So what is this H? Shall I say it's a heat or thermal power? It's a thermal power. So what is H? H you write it as dQ by dt. Look at the body. Body gains heat or loses heat? It gains heat, no? If a body gains heat, according to calorimetry, ms dt. Who will supply heat to the body? The source. Through what? Through the rod. The heat will flow through the rod. Please try to imagine. This is very important. So almost around 30 numericals are there based on this idea. Not 1, 2, 30, 30, 3, 0. Okay, now let me go for. So dt is equal to Ts minus T is equal to Ka MSL into dt. Let's go for the limits. What should be the limit? At T equals 0, what was the temperature? T naught. At any time, let T be the temperature of the body, that one. Okay, let's integrate this. This will be minus of log of. Can you remember? Dx by a minus x will be minus of log of a minus x, limit T naught to T. Ka MSL into T. Negative sign, let me sign down to that side. Substituting limits. No, log, this will become Ts minus T by Ts minus T naught. This is everything. I'll write it some alpha. What is alpha? That KATMLS. That everything will become alpha. Let me send log on that side. We have to justify our answer. I'm saying the temperature of body will vary with the time like this. Okay, let's do one thing. After a long time, what can happen? After a long time, the temperature of because the body will continuously gain heat. The temperature of the body should be that of source after a long time. So let's put T equal to infinity. Put T equal to infinity. E to power of infinity minus infinity will be infinity only. So e to power of minus infinity will be 0. The temperature of the body will be Ts. Am I right? Put T equal to infinity, what you write? Or say like a e to power of, this will become 1 by e to power of alpha t. Put T equal to infinity. 1 by infinity will be 0. This quantity will become 0. What is the temperature of the body? Will be Ts. Justified. T equal to 0, what was the temperature of the body? T naught. Put T equal to 0. This will become 1. Ts minus Ts plus T naught will be T naught. Okay, justified. After getting the answer, you should check for your validity. Means, did I apply limits properly? What is this? What we have brought it? Temperature of the body. See, in calorimetry, we have studied. We are going to supply it. How you supply? Through rod. See, what all in calorimetry, we just studied it is supplied. That's all. We didn't bother, sir, how I'll supply it? Here we are giving suitable explanation. Through conducting rod, I'll supply it. Able to get this? So can we plot this graph? Because the idea of that also needed. Maybe they may ask you some questions based on this graph also. We should be in better position. So initially, what was the temperature? It was T naught. Finally, it is Ts. And this is the temperature of the body. Exponentially increasing. Go back to the first graphical problems we did. So what is the curve? Curve will be exponentially increasing. This will be the curve. Okay, fine. The temperature of this body will increase exponentially, will not linearly. We thought, okay, but what this graph says, the curve says, it increases exponentially. When it will become temperature of source? After a long time. Many good questions will be asked for you. If I increase the mass of the body, I'll increase the mass. What can happen to curve? These are the types of questions what you can expect here. So if I increase m, if I increase m, what will happen to alpha? Alpha will decrease. If alpha decreases, if alpha decreases, how the curve? Your mathematics, say like now, don't ask physics teacher, sir, how the curve will be. You know enough mathematics, no? You should be able to interpret. So what are the type of questions what you can expect in exam? What all you studied, that only is, if I've set paper, no, the same question I just put it like, for M1 there's a curve, for M2 another curve. So can you say about M1 and M2? As M increases, what happened to curve? Will it be like this or will it be like this? If M increases, if M increases, so what do you expect here? Alpha will decrease. If alpha decreases, what happened? It should be like this. Analyze mathematically. So much is there to learn. Okay, now instead of this body, okay, let me keep there a block of ice.